Okay, our first unit will be on the constructive and deconstructive forces that change our surface. And the first thing we're going to talk about is our Earth's crust, which is made up of rocks. And yes, of course, you all rock. Okay, so our essential question for today is what makes up the Earth's surface or crust? So this is learning target 4. You should be able to explain and give examples of what type of rocks make up the Earth's surface and how the crust, which is matter, can be changed but not created or destroyed. This is the theory of conservation of matter. Okay, so notice these notes look a little bit different. I didn't put the lines in, but you know how to do Cornell notes. So this, remember, essential question goes at the top. Everything on this page is the right-hand side of the notes. So you draw a line and you'll put your questions on the left-hand side. Okay, so our first topic is a rock. A rock is a mixture of minerals, or it can be mixtures of pieces of rock. A rock makes up the Earth's crust. There are 3 different types of rocks. Okay, the first type of rock is an igneous rock. An igneous rock forms from the cooling of magma beneath Earth's surface, or Earth's crust, or the cooling of lava on the Earth's surface. So igneous rocks either form from magma beneath the Earth's surface cooling and hardening, or from lava on the Earth's surface cooling and hardening. Now, if you take a look at these 3 types of igneous rocks, okay, this type of rock right here is pumice, or it might be scoria. I think it's scoria. It is a igneous rock that formed from lava. One of the reasons why I can tell is that there's a lot of holes. These holes formed because the lava was exposed to air, and that created air pockets when the magma was cooling and hardening. This piece of rock is obsidian, and it also formed from lava cooling and hardening. It cooled so fast, that's why it looks almost like glass. And the igneous rocks that form on our surface from lava cool a lot quicker than magma beneath your surface. This rock right here is a piece of granite, which is what most of our Rocky Mountains are made up of. Granite formed from magma cooling beneath your surface. The reason why you can tell is it has all these different crystal colors. Those are from the different minerals that cooled really slowly so they had time to form and grow. And that's why a lot of your igneous rocks that form from magma have large minerals that might be different colors. Igneous rocks that form beneath the Earth's surface are called intrusive igneous rocks. These 2 rocks that form from lava on the Earth's surface are called extrusive igneous rocks. Really easy way to remember. Extrusive, think of lava exiting the Earth and cooling and hardening. Intrusive igneous rocks form beneath the Earth's surface, so like inside the Earth's surface. This is still on number 2. Another type of rock are sedimentary rocks. Sedimentary rocks are made up of sediments that have been compacted and pressed together. Sediments are broken pieces of rock from weathering. So sedimentary rocks form from other types of rocks that have already been formed. And what happens is weathering, which is a process through wind, water, or ice, that breaks pieces of rocks down into smaller pieces. Those are called sediments. Those sediments are moved through erosion and pressed and cemented together. Erosion, I'm going to underline that word because it's an important word. Erosion is the movement of those sediments. So again, wind, water, and ice can move sediments, and when they get moved and then pressed together, that can form sedimentary rocks. 75% of all our surface rocks on the Earth's crust are sedimentary rocks. And these are 2 examples of sedimentary rock. This, I believe, is a conglomerate. You can see a lot of the big pieces of rock pressed together. This one you can see forms layers. Sometimes sedimentary rocks have layers because they've been laid down. The sediments have been laid down on top of each other and created those layers. That looks like a piece of sandstone. The third type of rock, and yes, we're still on number 2, 3 types of rocks, is metamorphic rock. Metamorphic rocks form from existing rocks, either igneous or sedimentary, that have been exposed to heat and pressure. This happens a lot near plate boundaries, and we'll get into plate boundaries a little bit later on. But metamorphic rocks have to be exposed to heat and pressure. That's only going to occur where plates, where the surface of the Earth's crust has been cracked. Those cracks meet and press together, and that rock that makes up the Earth's crust gets exposed to heat and pressure. So metamorphic rock are already existing rocks that are exposed to heat and pressure, and they change the chemical makeup of that rock into a new type of rock, which is a metamorphic rock. Metamorphic means to change. Some signs of a metamorphic rock: if you see bands of layers that have been folded like this one, that's because of the pressure. Okay. And then a lot of times you'll see the minerals have been rearranged and they form, they're not quite layers, but they are kind of formed in layers, and that's a metamorphic rock. And these are all pictures of gneiss. Gneiss is a metamorphic rock that used to be granite. When granite is exposed to heat and pressure, it turns into gneiss. Okay, so let's talk about the rock cycle. So matter is anything that has mass and takes up space. Rocks are matter, and all matter or rocks can be changed. So all rocks start out as igneous rocks. All rocks form from magma or lava. So every rock that's been on Earth started out as an igneous rock. So if you look here in the rock cycle, I'm going to show you all so you can see it. Magma, when it cools and hardens, can turn into an igneous rock. Let me get my highlighter out. Okay, so when magma cools and hardens, it turns into an igneous rock. Now, the igneous rock can then turn into either a metamorphic rock or a sedimentary rock. If it turns into a sedimentary rock, a couple things have to happen. A rock, this igneous rock, has to be weathered and eroded, meaning the weathering, remember, is the breakdown of rock into small pieces called sediments. Then sediments, through erosion, get moved and laid down. That is what must happen to this igneous rock. It must be broken down through weathering into smaller pieces of rock called sediments. Then those sediments must be pressed and cemented together to form a sedimentary rock. That's called compaction and cementation. An igneous rock can also turn into a metamorphic rock. It will turn into a metamorphic rock if heat and pressure is applied to that igneous rock. Heat and pressure applied changes the chemical makeup of that igneous rock into a metamorphic rock. So that's how an igneous rock can turn into a sedimentary rock or a metamorphic rock. It can also go back as magma. So an igneous rock can melt and turn right back into magma. Now, if you take a look at the other types of rock, okay, sedimentary rocks can be turned into metamorphic through the same process as the igneous rock did, heat and pressure. So if you notice, every arrow that goes to the metamorphic rock, there's heat and pressure, because that is the process that creates a metamorphic rock. Okay? A metamorphic rock, in turn, can turn into a sedimentary rock. First, it has to get weathered and eroded, turned into sediments, and then compacted and cemented and turned into a sedimentary rock. Now, in turn, a sedimentary rock can turn back into sediments. Okay, it can be weathered and eroded and go back into sediments, then get compacted again and turn back into a sedimentary rock. So this is what we call a rock cycle. Oh, and I forgot one more thing. A metamorphic rock can turn into magma and melt and then go back to an igneous rock. Sedimentary rock, there isn't an arrow here, but it can also melt and turn into magma and then turn back into an igneous rock when magma cools and hardens. So this is called the rock cycle. Now, one thing I want to make sure you understand. All the rocks in the rock cycle, we don't create or destroy rocks. All we're doing is changing them. We'll change the igneous rock into a sedimentary rock into magma. So we are not creating or destroying any of these rocks. All we're doing is changing them. And remember, a rock is matter, so all we're doing to this matter is changing it. And yes, you are going to want to draw this rock cycle in your notes with all the labels that are on this diagram. Just a suggestion, I would do each one in different colors, like igneous rock and how an igneous rock in one color. Same thing how I did with the sedimentary rocks in blue, metamorphic in green, magma in yellow. Most of the time when I do this, I do it in red. And then igneous rock, I think I used pink. Okay, so what does this mean? This is a huge theory in science that you're going to see all throughout middle school. It's called the theory of conservation of matter. It states that matter cannot be created or destroyed, only changed. So when we look at the rock cycle, this is a perfect example of conservation of matter. You will see how this theory goes across all sections of science: biology, chemistry, physics, and geology, which is what we're looking at right now. So with the rock cycle, your rocks are not destroyed or created in the rock cycle. The rock is just changed from magma to igneous, igneous to either sedimentary or metamorphic, etc. So what we just went over, we don't create or destroy rocks. All we're doing is changing it. So the rock cycle supports this theory that matter cannot be created or destroyed, only changed. All the matter that we have here on Earth and in the universe, we can't create it or destroy it. All we can do is change it into different types of matter, which is what we did in the rock cycle. The rocks changed from different types of rocks. And just a reminder, matter is anything that has mass and takes up space. Rocks have mass. You can put them on a balance and get their mass in grams. Rocks take up space. So the Earth's crust, which is made up of rocks, is matter. Anything that's a matter can be classified as solid, liquids, and gases. Okay, so after these notes, hopefully you've got a better understanding of the different types of rocks and how they make up the Earth's surface, and the theory of conservation of matter, of how matter or rocks cannot be created or destroyed but can only change.